Men. And by the way, that's how it starts out. 3.11 times 10 to the 22nd atoms of oxygen. How many milliliters of gas are in 3.11 times 10 to the 22nd atoms of oxygen gas? Go ahead and begin that, ladies and gentlemen, while I get attendance and hand back your quizzes from last week, Friday.
No, we were. Yeah, I'm okay, actually. Mr. Brown,
Yes,
can you please look up what room I'm in for the ACT?
I don't have access to it. They're sending you an email today.
Okay.
They're sending you an email today. It will also be posted on the front office and in front of student services. But they are sending you an email today with what room you are in. Well, they don't want you to forget. That's all I can tell you.
So cool. Do this.
What? Well, that was kind of obvious after some of your quizzes last week.
Oh.
Well, it's true, though. It's not mean. You had chances to work on it, chances to ask questions. Some of you did, some of you didn't. Actually, I was going to postpone your test till today, your quiz till today. You can blame my fourth hour for that.
That would have been horrible. Who's in your fourth hour?
No. Nope. But you can retake tests. And you're going to learn from the quiz and not make those same mistakes again. That's what I can tell you.
How many millimeters of... I don't know how to do this. I'm done. I give up.
And I got an 80% on my AP test. And for me, that's good.
18, 6, and 8, 9, 10. Who am I missing? One more. Farhan here. Jennifer here. Hey, what was that?
I mean, sorry.
I missed what you said.
I said, oh dang it. I said, oh dang. Oh diggity dang. That's what I
Oh,
said.
diggity dang. Okay, sorry. That's what I thought you said, but I just couldn't hear you.
Wait, Mr. Brand, when we're typing into the calculator, do we do times E or just E?
Just E.
Okay.
Just E. E takes the place of times 10, and then you just punch your power in. Okay? Now, I will give you a few hints here, ladies and gentlemen. Not many, but a few. Here are your hints, ladies and gentlemen. These are the only conversions that you should be using. Okay? Number one, if you are using grams, you need formula mass over 1 mole, or you need 1 mole over formula mass. Now, this is the only one, ladies and gentlemen, where your number actually changes. It is based on what the formula of your compound is. Again, some of you are struggling to write formulas. Please, please, please come and see me if you need help writing formulas. Okay? Number two, ladies and gentlemen, is you may be in volume. Volume is liters. So you are either going to use 22.4 liters over 1 mole, or you're going to use 1 mole over 22.4 liters. That is the only way you will ever use that. That is it. Okay? The last one, ladies and gentlemen, is particles. Now, particles gets a little bit more tricky, only because we have to figure out what the particles are. But the conversion is always either 6.02 times 10 to the 23rd particles over 1 mole, or 1 mole over 6.02 times 10 to the 23rd particles.
Wait. From moles to volume, is that 1 mole over 22?
Okay, from moles to volume means that you're in moles. Moles have to be on the bottom. Volume has to be on the top.
This isn't turning on. Do you have batteries? Otherwise, I need 4 triple
AAA or double A?
triple.
I do not.
Are you sure Ava doesn't like double A?
Well, it says triple A. You want to double check?
That says AAA, and no, I do not have those. Sorry.
Can I run to Mr.
You can
Patterson?
use what?
Can I run to Mr. Patterson?
He has batteries for you.
Thank you.
Why don't you just use one of my calculators for
I
today?
don't know how to use it.
It's the same as that one, except not as complicated. For what we're gonna do today, you'll be fine. Okay? For what we're gonna do today, you'll be fine. All right, so hand those back, or get this done, ladies and gentlemen. Now, the only thing that is an extra thing in this one that is not over here is the what? Atoms. What is the smallest particle here for oxygen gas? What is the formula? O2. By the way, formula of a substance is something like this. O2. Something like this. NaCl. Something like this. MgCl2. I got these as formulas for a substance. These are not. These are conversion factors. Okay? These are facts that because 22.4 liters equals 1 mole that we can use to get from here to where we want to go. Now, this one does have an extra step, and that is this. In 1 molecule of oxygen, there are 2 atoms of oxygen, which means you are going to have 1 extra step besides these that we will show you, ladies and gentlemen. But everything you need to get from here to milliliters is on the board except for 1,000 milliliters equals 1 liter. Okay? 1,000 milliliters equals 1 liter. So here's the good news. This is about as tough a problem as I can give you. What? Probably, yes. I haven't written the test yet, so I can't say for sure, but problems like this will be yes.
Yeah, but I feel like
So, yeah. KP? Irizzi? You bet. Alexis?
Thank you.
Oh, it's because you're doing
Farhan?
times 10 and 8. All you have to do is 3.1 You don't have to do it. Yeah, you don't have to do that.
The EE takes the place of the times 10.
Yeah,
It takes the place of that part, and then you just punch in this number at it.
I think we did it, right?
Yeah.
What?
I've never
No,
tried
particle. Well, you can go from particles to moles, moles to volume, volume in liters to volume in milliliters.
Wait, so
But this one you have to begin with 1 molecule of O2 equals 2 atoms. Because that is going to be the number of atoms. Do it first. What unit are you in? Atoms, right? So make a conversion factor out of that fact at the top, just like we did over there. Which part of that goes on the top? Which part of that goes on the bottom? If you're beginning in atoms.
So would we just
That's really funny.
I hate it when people ask me that. Here's what I mean. When you set up what goes on top and what goes on the bottom, the 2's either going to be on the top or the bottom. If the 2's on the bottom, we divide by it. If the 2's on the top, we multiply by it. Okay?
I didn't get a grip.
Because unless I set it up, I can't tell you for sure if we're going to multiply or divide by it.
Tomato, color palette. I love,
would we only divide by 3.11?
Well, here's the thing. That's the number that you're beginning with.
I know.
So when you get all of your things into place, you're going to multiply by every number that's on the top of all of these conversion factors. And you're going to divide by every number that's on the bottom. Okay? Now, if you're doing it step by step, you start with that, then do the math for the first step. then do the math for the second step. It's up to you how you go about doing this. Okay? I'm just showing you the method that we use and how we set it up and how I think is the easiest way for you to do it. But again, you have to figure out what works for you. Wait. Sorry. As soon as I handed it to you, I realized I just looked at the first name and didn't know what to left.
Like, oh my god, Ashwaubenon, the prep show choir. We beat them. Yay.
Probably I'm happy that we didn't hit last week.
Wait, you guys did?
What we can get.
No, we got 7 because
Yeah.
Ashwaubenon moved from prep to open for Southwest. So we beat them. What's the difference? Basically, prep is like open, but it's like less. It's like you're less. We should be a prep. Like,
Okay.
Like, because we're.
It's like less skilled.
Wait.
Less experience.
Now, here's the thing. After looking at some of your quizzes, ladies and gentlemen, some of your quizzes, you were trying to go from moles to molecules or particles, but you weren't using this number. This is the number we always use when we go to particles. Okay? Now, again, sometimes our smallest part is a particle that is a molecule or a formula unit. We could then go even a little bit smaller than that into atoms. Okay? But again, these are the conversion factors that you are going to use 90% of the time. If we're going to milliliters, we need this one. If we're starting out or going to atoms, you may need this one, you might not. Okay? It depends on what your substance is. In this case, our substance is oxygen gas. That has a formula of O2. That is a molecule of O2, which means that is the smallest particle of that matter. But it is made up of 2 atoms of oxygen. So, if we look at this, ladies and gentlemen, the first conversion factor is to get out of atoms and to get into, molecules. So atoms and atoms cancel. Now you ask me, do we multiply by 2? Do we divide by 2? Well, all I know is atoms needs to be on the bottom here. And 2 atoms equals 1 molecule of oxygen. So in the end, we're going to divide by 2. Okay? This is the only way atoms will cancel out with atoms. Now we are left in the unit of molecules. Now, I didn't make you do this on your quiz. Okay? But the next step I did, which is we want to get out of molecules and into moles. This is the conversion we always use for molecules to moles. Now, molecules might be on top and moles might be on the bottom. The reason we have set it up this way is it is the only way that molecule and molecule will cancel here. So it is on the bottom. Okay? Now again, if you want to go through and do this step by step and get an answer each time, you are welcome to do that. But I will tell you this. 1, you're wasting time. And 2, you're taking the chance that when you punch numbers into your calculator, you're going to punch them in correctly. My doing it as one calculation completely means that there's only one chance for me to mess up punching numbers in. Okay? We are now in the unit of moles, but we want to get to milliliters. Well, we need a relationship between moles and milliliters. There isn't one, but there is one between moles and liters. So 1 mole on the bottom, 22.4 liters on the top. Why? So that our units will cancel out here. That is why we are doing this, ladies and gentlemen, to get our units to cancel out. So right now, if you were to look at it, atoms and atoms canceled here. Molecules and molecules canceled here. Moles and moles canceled here. I am now in the unit of liters, which is very close to where I want to be. I want to be in milliliters. And I told you, you can stop here, get an answer, and do this last part in your head if you want. I don't care. Okay? But you do need to go into milliliters. You just don't need to show me how. So if you're going to show me how, this is what you would have to do. 1,000 milliliters over 1 liter. Okay? Now, here's the nice part about this, ladies and gentlemen. This is how we are going to do every problem. in this unit and in unit 7. Every problem is going to be set up this way. You are going to go through these same steps. You're going to take what you're given and you're going to convert it. Now, the first thing we have to do is take what we're given and get it into moles. Why? Because the mole is the central unit. From the mole, I can go to any other unit I want. I can go to mass, I can go to particles, I can go to liters. Any unit that I want. But we got to get through the mole first. So that's what I'm doing. I'm taking what I'm given and I'm getting it into moles. That's this part right here. Here I'm in moles. And now I take and I come out in the unit that I want. I want to be in the unit of milliliters because it says milliliters here, but I got to get to liters first, then milliliters. Now, in your calculator, 3.11 times 10 to the 22nd. And again, the EE button takes the place of the times 10. You don't need to hit 3.11 times EE. All you need to do is hit 3.11 and the EE button. And now punch the power in. 22 times 22.4 times 1,000. Numbers on the top don't need to be in parentheses. Why? Because until you hit the division key, it's going to go along and do the math that you've been asking it to do. That's the way your calculator works. It says take this number times this, then times this. Now, when you hit division, now it gets tricky. Why? Because I'm dividing by two numbers on the bottom. And the only way you'll get the correct answer, well, there's two. One is to hit divided by and divide by 2. Then divide by 6.02 times 10 to the 23rd again. Why? Because your calculator takes each operation as an individual step. Instead, what I like to do is these two numbers. After I hit division, I put them in parentheses and multiply them together. If you do that, you're going to get the correct answer. You could also get the correct answer by dividing by 2, then dividing by 6.02 times 10 to the 23rd. Either way will work with your calculator, ladies and gentlemen. Either way. And this is what you should end up with. Now, sig figs. 3 sig figs here. 3 sig figs here is the 9 in the ones place. The 9 after it says round this up. The problem is if that is a 0 at the end of a number, is that 0 significant? Zeros at the end of a number, are they significant?
Only if there's a decimal.
So I have to put the decimal point after the 0 to make it significant. That is making that 0 significant in this problem. Questions?
I am not getting that number.
Yeah, no, me neither. Sophia, what did you get?
578.
Yeah, us too.
that's what we
Okay, well, let me check and make sure I did mine correct.
Okay, so you got that, so you divided by that, times 10, yeah.
Oh, you know,
my goddamn calculator.
just so you know, ladies and gentlemen, your calculator only gives you an answer for what you punch in. So yes, 579, 579 milliliters is what you should have gotten. Sorry, 579.
See, you just wasted 3 minutes of our learning because you got
Whoa.
Hey, but you know what, Mr. Bramler?
Hey, you know what? It just goes to show you that sometimes even people who know what they're doing can make mistakes when they punch things into their calculator.
It's because
Now-
you didn't punch it in after.
No,
Yeah.
it isn't, because if I would have done it the other way and still used 24 instead of 22.4, I would have still got the wrong answer. But by putting it all in at once, I could go up and I could see the entire calculation, so that made life a little bit easier for me.
Yeah, I went to read all the pages and put them in my binder. Because I'm writing all the formulas that I need to know for the ACT.
I do need to write, I need to go through and memorize all the geometry ones.
Yeah, I
Okay.
wrote them all.
Now, because, ladies and gentlemen, this doesn't end in a 0, now I don't need that decimal point there. There are my 3 sig figs. Good. Questions? Good. Take out your quizzes and let's take a look at them. Okay. There were two different versions of the quiz, ladies and gentlemen. So, if you had V1 and V2, you had two different versions. So please look at the correct version. Up at the top, if you have V1, ladies and gentlemen, or it just says Unit 5, Quiz 1, these are the 4 answers from your quiz, ladies and gentlemen. Now, the last problem should have been a 6-point problem, and the third problem should have been a 4-point problem, so I adjusted those. I also only graded the top 3 questions on your quiz. The 3 questions that you got the highest score on are the 3 that I graded, and I gave it to you out of 15 instead of out of 20. Okay? So some of you did fine on all 4. Some of you did not. Okay? Again, I thought you could have used a little bit more time, but since 4th hour ticked me off by not working very well the other day in class, I decided we were going to see what you know, because here's the thing, we got to move quickly anyway. Okay? So for the first one, 75.8 times 1 mole over 95.21. That is the formula mass of magnesium chloride. Please remember, magnesium, 24 point something, 08, I believe. And then the sodiums are 35.45, but there are 2 of them there. So that's how we get the 95.21. This number rounded into 3 sig figs would have been 0.796 moles of magnesium chloride. This is the substance formula I was looking for, MgCl2. For number 2, the substance formula was H2. We start out with moles, we go into liters, liters into milliliters. Again, you did not have to show me this step, but you had to do it. And you should have come out with 1,830 milliliters of H2. Why 1,830? Because this number had 3 sig figs. That is all this number could have. So that is the number 1,830 would have been the correct number of sig figs in milliliters. The substance at number 3 was silver chloride. You were given molecules. We use 1 mole over the number of molecules. Answer should have been 3.82 times, or 3.82 moles of silver chloride. And finally, our last one, ladies and gentlemen, the formula should have been Ni3. 71.8 grams times 1 mole over 394.71. Times 22.4 liters over 1 mole gave us 4.08 liters of Ni3. Anyone have any questions on that? I will show you those of you who had version 2 in a second. Go for it. Okay, go ahead.
Actually, I don't know. This makes sense. What you're wrong. I'm screwed for science.
Well, here's the ones for version 2, and I'll come over and look at yours, Cynthia. How's that? So the substance was calcium fluoride instead of magnesium chloride. What's your question? Well, yeah, because that's not the right formula, and I hadn't gotten to that one yet because you were looking at the other answer key. Zinc is a +2, oxygen's a -2. That should be ZNO.
They're like, where have you done that?
Right, which you reduce to ZNO. Because a +2 and a -2 cancel each other out.
You got the point.
But you didn't, because you didn't have the right formula. ZNO2 is not the correct formula. ZN2O2 is not the correct formula. Okay, so for calcium fluoride, ladies and gentlemen, you have 1 mole over 78.08. Your answer should have been 0.824 moles of calcium fluoride. For the second one, the formula was O2 for the substance. Again, the moles times 22.4 times 1,000 milliliters over 1 liter. This answer should have been 1,780 milliliters of oxygen. 1780 is 3 sig figs. Formula for zinc oxide is ZNO. A lot of people forgot to reduce that. To be honest, it had no impact on the rest of your calculation because I didn't make you use grams for it. So 1 mole over 6.02 times 10 to the 23rd molecules. Molecules and molecules would cancel. Final answer, 6.41 moles of zinc oxide. On the backside, ladies and gentlemen, you had sulfur tribromide. 1 mole over 271.76 grams. 22.4 liters over 1 mole. Final answer, 6.86 liters. Questions?
Wait, did you?
I'm listening.
Okay, so look, come here. I'm gonna show you. You have to see it to understand it.
I have already seen it once. You understand that, right?
Well, I'm confused. Is it because I did it wrong?
No, that's because that's the wrong number. Mine is 1,780. Yours is 177. You just dropped
No,
it a place.
177, 6.3.
Right.
I know.
What place is the 1 in? How many places beyond the decimal to the left? Mine is 4. Yours is only 3.
You said it was 3.
It is, but you took $1,770
Oh.
and you settled for me giving you $177.
See, you're not supposed to put a 0 on it.
You changed the value of your number.
I didn't put a 0 on the other store.
You should have. You changed the value.
Yeah.
It's like Kiana loaning you $100 and you paying her back 10.
No, don't explain like that. It doesn't make sense.
So it's because of the number that you got, this one, right?
Okay, walk away from me one.
4 numbers, 1,776, you have 177.
You're the one who was talking about. I
Oh,
wanted to.
Yeah.
So.
So the extra 0 at the end.
So how come you have 177,
Because the program that I use to write these doesn't give me an answer in sig figs. I have to do it afterwards.
Okay.
So none of those some happen to be in the correct sig figs. Most are not because the program can't give me the answer in sig figs. I have to do it afterwards. Okay? Questions?
So if I would have added a 0, it would have kept this value.
Yes, it would have.
Okay, that makes sense.
You had the right amount of sig figs. You had the right unit. You just didn't have the right number mathematically by dropping that 0. Now, you also didn't round it correctly because it should have been 1,780 or 178. But again, little things like that, I guess, we'll have to deal with along the way. Okay? Questions? The quizzes are yours to keep, ladies and gentlemen. Now, all right, here's the good part, here's the bad part. We are very rarely, after this unit, going to use particles. Very rarely. In other words, at 6.02 times 10 to the 23rd, we will not use it very often. We can, but we will not. Okay? Also, after this unit, we're probably not using I guarantee we're not using 22.4 liters equal to 1 mole, because after this unit, nothing will be at STP.
Oh.
Okay? But that's the entire next unit is gas laws. Don't worry about that. Formula mass, we are going to constantly use from now until the end of Unit 7. Constantly. So that is the important one, ladies and gentlemen. And that is because formula mass can be used in more than one way. So for example, ladies and gentlemen, let's get to this. Slide number 21 in your notes, ladies and gentlemen. Get to there. Now, name me a compound.
Any compound?
Sure. What?
NO2.
NO2. Nitrogen dioxide. Okay? That is our compound, correct? Okay, what is in NO2? How many? One atom of nitrogen, two atoms of oxygen, correct? Right? Okay. Now, if we were to find the mass of this, what unit would it be in based on atoms? Nope. What unit would it be in for the mass of an atom? Grams are a much larger unit. If you're talking about one atom of nitrogen, it is not measured in grams. It's measured in AMUs. Well, one atom of nitrogen would be 14.07 AMUs, correct? Two atoms of oxygen would be 32.0 AMUs, correct? The problem is we can't work with that. Why? It's too small. It's just simply too small. So instead of one molecule of NO2, we take one what? 1 mole of NO2 molecules. Because what does that do to our masses? Into what unit? Grams. In 1 mole of NO2 molecules, instead of one atom of nitrogen, there is one what?
Instead of one atom of nitrogen.
Correct. If we take everything here times, there's 1 mole of nitrogen atoms. Correct? Okay. How many oxygen? So all we have done is taken everything and multiplied it by the mole, correct? Which means what would be the mass here now? Come on, formula mass for 1 mole of nitrogen atoms.
14. So they're the same thing?
Nope, because the unit is now what?
Oh, grams. Okay.
And what's the oxygen?
32.
Now, 0.1, sorry.
I was confused.
Sorry. 1. Let's make that a 1 then.
So it's the same thing as Formula Max.
Correct. Correct. Now, here's the thing though. Which is an easier ratio? 1 to 2 or 14.01 to 32.0? 1 to 2. Why? Because it's shown right here, correct?
Yes, it is.
But there's still this ratio in this compound, correct? 14.01 AMUs to 32.0 AMUs. Over here, there's still this ratio in grams, but also a ratio in moles. Which one is more useful to us? What? Why?
Wait, what'd you ask? I'm sorry.
Which of these two ratios is more useful to us or easier for us to find? This one or this one? Why?
Because it's more like simplified?
More simplified.
Like, yeah, 1 to 2.
Where do we get this ratio from?
From the formula.
Where do we get these masses from?
From the formula.
From the formula. So they're both ratios that come from the formula, correct?
I guess.
But this is the ratio shown at the bottom, correct? This is a ratio we have to calculate based on mass and how many there are, right?
Yeah.
So which one is easier for us to use?
The one that we can just
Probably
look
this
at
one.
and find.
Good. Point being, ladies and gentlemen, every formula that you write is also a molar ratio of one element to another. Okay? Every formula. That's why we use the mole. We use the mole because what we're saying is on the very smallest level, one atom of nitrogen combines with 2 atoms of oxygen. We can't work with that level. It's too small. We can't see it. The level we can see is when we have 1 mole of nitrogen atoms and 2 moles of oxygen atoms, but it's still a 1-to-2 ratio, correct? Always. Good, because what that means is we can figure out the formula of a compound. We can figure out the formula of a compound. And that, ladies and gentlemen, is what we are going to be beginning today. Now, here's the problem. There are 3 types of particles. What are they?
Molecules, atoms, particles.
Come on, FU.
Formula units.
Formula units. Those are the 3 types of particles we can have. Well, ladies and gentlemen, there are 3 different kinds of formulas. Formula number 1, ladies and gentlemen, is called an empirical formula. An empirical formula is a formula that is written in lowest terms. Here's the good news. We have been doing that all along. Every single ionic compound is an empirical formula because they are always written in lowest terms. Because as Cynthia found out on the quiz, if you don't reduce that 2 and that 2, and some of you also found this out, it's wrong. Has to be in lowest terms. So, good news. Every ionic compound that we have been writing is already an empirical formula. Not much to worry about there. It shows the ratio of all of the elements in the compound. The ratio by what? Ratio of what in the compound?
Molar ratio?
Moles or atoms. Either one. 1 atom of this to 1 atom of this, 1 mole of this to 1 mole of this, which we can then take and make a molar formula out of, a molecular formula, or a molar mass out of, or a formula mass out of. The ratio in the formula is a molar ratio of the elements in the compound. 1 sodium to 1 chlorine, 1 mole of each. 2 moles of hydrogen to 1 mole of oxygen, water, H2O. Okay? The second type of formula is called a molecular formula. A molecular formula is the formula for a molecular compound. A molecular compound is what? What makes a molecular formula different than an ionic? What? In a what? Nope. Well, you are at least the closest to give me an answer.
Oh, ionic is metal, non-metal.
Ionic, empirical formulas are metals and nonmetals. Molecular are?
Metals and metals. Or non-metals and non-metals.
Thank you. Nonmetals and nonmetals. Does dinitrogen tetraoxide, N2O4, need to be reduced? No. Matter of fact, we're not supposed to. So a molecular formula is not necessarily in lowest terms. Some molecular formulas are. Carbon monoxide, CO, is in lowest terms. Even carbon dioxide, CO2, is in lowest terms. C6H12O22 is not. It's not in lowest terms. If you can take and reduce it, it is not in lowest terms. But molecular formulas don't have to be in lowest terms.
That's so great.
Okay? Well, it's going to create a problem for us a little later on, but we'll get to that bridge when we need to burn it. Could be in lowest, does not have to be. And then, ladies and gentlemen, there is something called a structural formula. A structural formula is a formula that shows not only all of the elements, but it also shows how they are put together. So, for example, ladies and gentlemen, there is a formula, C4H10. This compound is found in lighters. It is called butane. It is the liquid that is in a lighter that you get from a mini-mart, a disposable lighter. Its formula is this. One, two, three, 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. That's the formula for it. However, it could also be this. One, two, three, 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens.
So it could be like
It could be any way.
put together a different way, but it has the same amount.
Correct. Correct.
Wait, what does that mean for us?
Nothing. We're not going to worry about those. But they do exist.
Okay.
And actually, this is butane. This is methylpropane. Two totally different compounds. Simply because they're put together differently. Wait,
But how
the
do you-
science of the study of matter, its structure, composition, properties, and the changes it undergoes. Structure. Structure matters.
Structure matters.
Question.
Like if like you would write just C4H.
I'm not expecting you to know this. Don't worry.
Oh.
Get into college, take organic chemistry, pull your hair out for 12 weeks or however long the course is. Have fun. Okay?
I don't do that. Is that why you don't have any more hair?
What?
Did you-
All of it is still there, Cynthia. You can come pull on it. It's all mine. And unlike Mr. G, it's better gray than gone. Okay?
No,
So-
was Mr. G just like balding and he decided to cut it
He
off?
decided to go full on.
I've seen,
Take care.
I've seen pictures. I'll visit you every year until I'm gone to make sure that's still going.
That's fine. My grandpas both had a full head of hair when they died in their late 80s, early 90s. So I'm not worried about hair.
What if we like buzz cut it while you're sleeping?
What if I put Nair in your shampoo?
First of all, I got bigger problems because how did you find out where I live and how did you get in my house? I understand. Finding out where I live is not hard.
Was there?
But just remember the security cameras, I'm going to have you on them and I'll know who is coming over.
Oh my god, you're crazy.
So-
Would
What?
your wife love you if you were bald?
I don't know. You'd have to ask her. So, all right. So, structural formulas are like molecular. They could be in Lois. They don't have to be. Okay? Now, here's the problem with this formula, too. It is a molecular formula, which means it can be what?
Are you 53?
What?
Are you 53?
53 what?
Years old.
Why? Don't I look it?
Well, no, I'm just finding out.
I'm just like.
I just found a website.
Okay, congratulations. There's all kinds
No,
of
it's
them on the
just, like,
internet.
53. I don't know. It doesn't.
Yep. Yep. So guess what?
Oh yeah.
The freshmen, I like the freshmen this year. Why? When they leave, I leave.
And some being creepy.
Okay.
Continue.
Oh, this is your last year?
Oh,
She
they
didn't
leave.
listen.
So you
Didn't
have 4
listen.
more years? That's a long time.
My sister
Wait, how old is
is
Miss
my
Lucky?
sister's 60 something. She's 55.
And she's retiring this year. so-
Yeah, I know. She's got a good husband who takes care of her at home.
You don't have a wife.
I can take and I can reduce this, ladies and gentlemen. What would we reduce this to?
C2H5.
Which would be its empirical formula.
Okay.
That is different from its molecular formula. We're going to see how that's going to
Is that
affect
still
us
bu-
later
it's
on.
still butane then?
What?
Does it change what it is then?
Well, here's the thing. An empirical formula just tells me the ratio of the things in the formula in lowest terms. If it's ionic, it's going to tell me its formula because all ionic have to be reduced. If it's covalent, C2H5 is not butane. It's not. But it is the ratio of the elements in butane in lowest form.
Yeah.
Okay?
This seems really confusing, Mr. Brand.
Don't worry, it gets not easier. Okay.
I thought you said we didn't have to worry about this. Unless we made a call over it.
Okay. So, ladies and gentlemen, a sample contains 12 grams of calcium and 21.03 grams of chlorine. We're going to find its empirical formula. Basically, when you're given information and you have no idea what to do, what do?
Give up.
Cry.
Nope. Good answers, but neither one are acceptable in this class.
Wait, what?
If you're given.
If you're given information and you have no idea where to begin, what did I tell you should do in this unit?
Put the thing on the bottom.
Can you put one number first?
Start with the number that you're first given.
It's good to know you listened, and it's good to know you didn't hear a word I said.
Sound
Yeah.
like my mom.
When you are in search of something to do with what you're given,
Yeah.
get it into moles.
Oh.
Why? Because when you get it into moles, you can go wherever you want. So, ladies and gentlemen, we are going to take what we're given and we are going to get it into moles. But I need two different conversion factors. For calcium, I need 1 mole of calcium is equal to 40.08 grams. Hey, good news! Not calculating formula masses here, am I? Because these are just elements, okay? Just elements. And by the way, chlorine here is not going to be Cl2. Why? Because it's in a compound. It's not alone. It is already part of a compound. So, I need the formula mass for calcium and I need the formula mass for chlorine. Questions?
No.
Good. So now I'm going to take what I'm given, 12 grams of calcium, and I'm going to get it into moles. So I do that by putting 1 mole of calcium over 40.08 grams. That will give me an answer in moles, correct? Yes, it will. Good. Trust me.
Do we need
Now-
to write the? Sorry, I should have raised my hand. But do we need to write the Ca because I remember
Here, I would because we are talking about two different substances.
Okay.
And it's a way of keeping them straight when you're doing your calculation. So at the beginning, I would probably put Ca. You don't have to here and here. But yes, at the end, yes, you're going to want to list moles of calcium.
Okay, thank you.
Okay? Now we are going to do the same thing with chlorine. We're going to take what we're given and we are going to get it into
Moles.
using,
Grams.
which we also call, starts with formula, ends with mass.
Formula.
Formula mass. 1 mole over 35.45 grams. Again, not Cl2 because we're part of a compound. And we are going to get the moles of chlorine in the compound.
Is this gonna be on ACT?
No, they don't do anything this hard in science.
No, the
In science, read the graphs, look at the question, and figure it out. It's not about science knowledge. It's about reading and interpreting graphs and diagrams and datas and things like that.
Even worse.
No, I like that better.
Okay,
That's you.
so now what I have here is a what ratio?
1 to 1. No, sorry.
0.299.
0.593.
Ratio of elements.
Thank goodness. Yes, Mr. Brand here.
Molar ratio.
Yep,
Me when I'm bored, I'm gonna talk to you.
with everything. Okay, we'll do. Okay, bye. You,
What?
you're out of here.
No, please.
Go.
Wait,
Take all your crap and go.
Where am I going?
Wait, actually?
You're going. You're gone. You're out of here.
Where am I
Wait,
going?
no, I didn't hear it.
Where am I going? Where am I going?
Come on out here and I'll tell you.
He was actually talking to
Okay,
himself.
one second. All my stuff?
Yeah, everything. Your headphones, your book underneath.
Okay, yes.
Let's go. Sometime today, you're killing my class time here. Let's go. Let's
A
go.
little unexpected, Mr. Brand. I can't.
Hey, they called, they asked for you. I gladly gave them. Come on, let's go. The only sad part is they wouldn't take anybody else with you. Sure, knock over all of Angel's stuff. It's okay. She's just sitting there trying to do her
Oh
stuff
my
and you're
goodness,
messing it up.
Mr. Brand.
Let's go. Get out. You're welcome. Okay, so what kind of ratio is that again?
It's small.
Molar.
It's a molar ratio. The problem is, look at our numbers.
They're not clean. They're not perfect. They're not nice. They're not nice.
How about we go with whole numbers?
Yeah. Yep.
They're not whole numbers. How do we make them whole numbers?
You don't.
Divide.
What? If we divide those by 100, all it's going to do is make it 0.00299.
So you multiply by 100.
No, then that's going to make it 29.9. That still doesn't help us.
You round up. We're done.
Nope.
You said 1 more. I don't
Over 1.
That doesn't change anything.
know.
What would change is if we take these two numbers and...
Add them together.
Divide.
Olivia, you want to give it a shot? I didn't know if you were raising your hand there. What?
Put them over each other.
No, you divide by the smallest amount of moles. Because what's that going to guarantee this is?
1.
1. Most whole number ratios have a 1 in them. Not all, but 1. So we divide by the smaller amount of moles. This becomes 1. This becomes 1.98, which is close enough that we will round it to 2.
It's just not.
So what's the formula for calcium chloride?
CaCl squared.
You can't square.
I mean, subscript 2. Oopsies. Don't get mad at me.
Your formula, CaCl2.
See, at least I answered.
You did, and I appreciate that.
Thank
We just need to learn where squaring goes on a thing, but you had the right idea.
you. Man, I just got an AP.
Hey.
I just AP stats. Okay?
So,
It's hard.
then don't take it.
Okay. I wish.
Okay. Well, it's a class you
No
chose
one
to
forced
take.
you to take it.
What?
Yeah.
But why couldn't we just look at the periodic table? Because
Well, you can. The question is, can you prove it?
Oh.
And does it work with ternary compounds?
No, I can't prove it.
What's that?
I can't prove it.
How?
Because you taught us it.
Okay, so tell me how you would prove it.
If it wasn't true, then you
Tell me how you would prove it.
Prove it right now.
Tell me how you would prove it.
Same periodic table.
Tell me how you would prove it.
Everyone uses the same periodic table.
I understand that, so tell me how you get that formula.
From there.
How?
The crisscross.
Shh. She's dying on her own. Don't throw her a lifeline now.
Yeah, whatever she said, the crisscross method.
Which is what?
Wait, crisscross method, the charges.
It's
Wait.
amazing. It is great. It's like watching a little kid drowning in a pool and you don't really want to jump in quite yet because, you know, they still got a little more time and they're struggling and they're like
sound
yelling.
like you're talking
You're
from
so
experience.
No, that's actually like awful, Mr. Brandon.
Now I
Let
don't
little
feel
kids
I
bad
would
for
not
trying
let a
to
little
act.
kid
You let
drown.
little kids
It's okay. I'm
drown.
CPR certified anyway.
Why
Don't
are
worry.
you a
I
teacher?
am.
Genuine question.
Are you part of like the?
So you
part
are
of the
right.
attack team?
Sophia, if we go to the periodic table, calcium is a +2, chlorine is a -1, we would get this same compound formula.
Mr. Brandon?
However, we can't do this with all ternary ionic compounds. So,
So this is just a
You
prove
start
it.
singing a song during
it
it.
is a way that we can. Oh, look, a ternary ionic compound. How do we know it's ternary?
Three.
Because we got 3 things in it.
This seems complicated.
So, no, it isn't, because we're going to do the same steps we just did.
Yeah, it's a lot of
In other words, find the empirical formula of a compound that is composed of 30.7 grams of sodium,
Oh my God.
69.4 grams of chromium, 74.7 grams of oxygen,
Okay, first.
and then we're going to name the compound.
First, we get it in a mole, right?
We take what we're given and get it into mole. But to do that, I need the molar masses. For sodium, 22.99, chromium, 52.00, oxygen, 16.00. Everyone understand where we're getting those numbers from?
The periodic table.
Good. So we take our 30.7 grams of sodium. We get it into moles. How? 1 mole over formula mass. We then get our answer in moles. Take the grams of chromium times the formula mass. Same exact step, just a different number on the bottom because we're talking about a different element. Gives us a certain number of moles. Questions?
Whoa, slow down.
74.7 grams of oxygen. 1 mole of oxygen over 16.00 grams will give us the moles of oxygen.
Oh, give us a second. Mr.
1,
Okay, give us more than a second, Mr. Brand.
1, 2.
Your knee slapper right there. So then we just divide everything by 1.33.
Why?
Because it's the smallest.
Very good. Congratulations. You've just figured out how to do empirical formulas.
Wow, that's it.
No, not quite, but pretty much.
And then you gotta multiply it by 2.
What?
I don't know, that's what you have it on the page.
Why would you have to multiply by 2 when we just divided by something?
If the ratio comes out to be a decimal, we need to multiply to get it whole numbers. That's how you do it.
Huh. So what you're saying is we're dividing all of these by the same number, that 1.33 that Cynthia found, all on her own. Good job, Cynthia. So this comes out to be what?
Like 0 point, like a really small number.
Really?
It's gonna be like 1 point.
Okay,
and
like
then
1.
something.
Like 1. 1 point something.
Yeah.
This comes out to be exactly 1. But this comes out to be 3.5.
Yeah, multiply by 2.
Why?
Make it a whole number.
Okay. Some ratios, when you get them, ladies and gentlemen, are not 1 to something.
Door.
Dang it.
Oh.
Hi! Glad you're back!
Hi.
We missed you.
We missed you.
You made her take all of her stuff when she was gone for literally like a minute.
First of all, when they called, they said tell her to bring everything with her.
Well,
How am I supposed to know how long it takes for a meeting with someone
I
else?
thought you knew everything.
Exactly.
I thought you were smart.
Everything but
No, I just I've said it before and I'll say it
Wait,
again.
so why are we multiplying by 2?
Well, listen and I will tell you. I was trying to tell you when we were so rudely interrupted by Alexis coming back to class.
That's not her fault. Don't blame her.
Yes, it is. She knocked on the door.
I have to turn around if you yelled at me like that. Okay, but it's your fault because you're the one teaching class right now. Maybe just don't.
Right, because that's not what I'm supposed to do in this time frame right now.
Oh, and
So, ladies and gentlemen, when you end up with decimals, if we're talking about 1.01, we can round that to 1. If we're talking about 0.98, we can round that to 1. We're talking about 2.01, 1.99, we can round those. We cannot round 3.5. 3.5 is a number that we're not just going to round up to 4. Why not? Because it's not a 1 to 4 ratio. Instead, it's a 2
To 7.
to 7 ratio. Okay?
We're multiplying all of them by 2.
We're multiplying everything by 2. Yes.
You do that if one of them is.
We do it that if one of them is a 0.5. Now, here's the thing.
Only if it's a 0.5?
Listen, I'm going to give you 3 numbers.
Okay.
Okay? So, if you get a 0.5, you are going to multiply by 2. If you get a 0.33, you are going to multiply by 3. And if you get a 0.25, you will multiply by 4. I will not give you any that are not one of those 3. Doesn't mean there aren't ones out there that don't exist, but I will not give you any that are not that way. Okay? Now, remember, this is after you have divided by the smallest amount. So you can't look at these numbers right away and go, well, that's 0.33. Let's round that. Let's take that times 3. No. We have yet to get it into where we have at least something that is a 1. Okay? Now, we are now going to go back and we are going to multiply everything by 2. All 3 of these things. Why? Because it's a ratio. What you do to one thing in a ratio, you have to do to the others. So, what will our formula be?
Na2CR2O7.
Na2CR2O7. Now name it.
Sodium dichromate.
Where'd you get dichromate?
That's CR2O7.
Thank you. On the back of your periodic table is CR2O7. Dichromate. Now, you and I could never get this formula unless it's this way. Why? We don't know if it's going to be chromate, dichromate, chromite, dichromite, hypochromite, hypodichromite, perchromate, or perdichromate.
Wait, what was the name of it?
Sodium dichromate.
But there's 2 sodium.
Right, but we don't have to worry about naming that because it's an ionic compound. We are naming the metal, sodium, and we are naming the polyatomic, which happens to have a dye in it.
Yeah, my bad. Okay.
Questions? Yes. Hurry. Questions? it. All right, let's check the next one. Questions?
There's nothing on here for that?
Well, they're more like this, because what's different about this one?
They're all
Why is there
percentages.
percentages?
They're all percentages. Oh my God, what are we going to do?
Oh wait, nothing, because it's just a percent of 100, right? So you just get rid of the percent then, and it's just 38.13.
That's it.
It would be in volume, wouldn't it though?
Moles.
No, grams still.
MN.
Here's the nice part about percentages. You get to pick the sample size because it's a percentage. Now, what is the best sample size to pick?
The same. Like,
Pick a sample size. One what? I wouldn't pick 1 gram. I wouldn't pick 1 kilogram. I wouldn't pick 1 mole.
1%.
How does that help you get rid of percent? What amount should you pick? You were so close at the
One
start.
particle. One volume.
100
100 what?
Grams.
Pick
grams.
100 grams because then the percentages automatically become
No percent. Absolute that.
become
Number. Not
Just
they become okay.
gram.
Minute.
What's 38.13% of 100?
38.13.
Okay, so what's 38.13% of 100 grams?
38.13 grams.
Thank you. Pick 100 grams.
Yeah, that's why I said that the.
I'm agreeing with you. Pick 100 grams. Okay? Because now all our percentages become grams. And again, we're going to assume a 100-gram sample. After that, we're going from grams to what?
Moles.
Moles. Assume 100 grams, and we can convert them into grams out of percentages. Questions? Are we clear on that?
Wait.
If you wanted to do 1 gram, you could. It would work out. But you're going to have to take 1 gram times 38.13% and find what you get. The ratio is a ratio by grams. It's also a ratio by percentage. Okay? So you could pick any sample size you wanted, but the easiest sample size to pick is 100 grams because your percentage automatically becomes grams. Now we take everything and get it into
Moles.
moles.
Okay, so wait. So we do take the percentage and we divide it by 100.
No! You multiply it by 100.
Okay, we multiply
And you-
it by 100.
And you literally don't have to do anything. You just get rid of the decimal, or like the.
You get rid of the percent sign and change it into grams.
Yeah.
So basically, we don't have to show the math for that. We can just.
No, you don't.
Okay.
No, you don't. Good point. You don't. No, not at all. But you do need to change them correctly.
What does the MN mean?
Manganese,
Oh. Okay.
carbon, oxygen.
Okay.
And then do what we've been doing. Take what you're given, convert it into moles. Get your molar ratio. The problem is your molar ratio doesn't come out to be small whole numbers. So how do we make our molar ratio small whole numbers?
We divide.
By
Small sum.
we divide by the smallest amount of moles. That is awesome. You guys are doing great with this. I'll let you get caught up because I know you take a little longer to type. Don't give me that look, Alexis. It's not my fault you went away.
Okay. It's not my fault either.
Well, we can agree to blame Mrs. Kong then, okay? So you go tell that nice lady that you're
Okay,
blaming her
no,
for all
I'm
of
not
this.
No.
You're the one who first blamed Mrs. Collins.
Mm-hmm.
I'm not blaming anybody other than Alexis. If she had had her stuff done, she'd have never gotten called down there.
I did have my stuff done. That's why I came directly back, Mr. Brand.
That was gone for a long time for coming directly back.
It's the stairs.
What'd you do? Take the long way by the gym or what?
No.
so it's all over 0.694.
All over 0.694, correct. So again,
Show us the answers.
one is going to come out to 1. Well, just relax. You could do a little math on your calculator.
No, I know what I'm doing.
You can't take 1.4 divided 0.694 and tell me what it gets.
That's so much work, and you can just click a button and
With their
pop
both
up.
694?
We always divide by the smallest number.
All of them.
All of them.
No, but I'm saying 1 mole of Mn is like we have 0.694.
That's why I picked 0.694. It was the smallest.
Oh, I wrote the wrong thing.
But 1.4 divided by 0.694 is approximately how much?
2.
2. 2.78 divided by 0.694 is 4. Oh my gosh, tough math here, ladies and gentlemen. Tough math here.
The MN1,
Keep going.
C2,
Okay.
and O4.
Last time I checked, that would be your formula. MN1 C2O4. Now name it. What?
How do you say that? The MN.
Manganese.
Yeah, that 2 oxalate. But
Manganese?
don't you say 2?
You should put it in there, but because I didn't tell you.
But you would know
You would-
because the oxalate has a charge.
Correct.
too.
Very good. Very good. It has a charge of -2, so it has to have a +2 to balance it out. Yep. Very good. Very
Would
good.
you take off points if we didn't have the 2?
Not if I didn't tell you specifically that you needed a Roman numeral. I do not expect you to know when to use Roman numerals. Okay? I would have to tell you. But you're right. There should be a Roman numeral in there. And it should be II.
Wait, wouldn't it be MN2CO2O4? Because
No, the MN, there's a 1 by it. Why would you? The ratio says there's 1 MN. Why would you put a 2 by it? Your formula comes from this ratio. This ratio. 1 to 2 to 4. 1 to 2 to 4. Don't change that. Manganese is in a spot where we cannot tell its charge on the periodic table.
Oh, okay.
So that is what Sophia was just saying. Don't we have to put a Roman numeral of 2 after it? And I said I wouldn't hold it against you because I didn't tell you that you specifically needed that.
So we would add it to because oxalate has a charge 2.
Oxalate has a charge of -2, which means manganese has to have a charge of +2. So that's where that 2 comes from. Now, here's the good news. On Wednesday, when we come back to class, we will give you tons of time to work on these. So that way, when you take your quiz on Friday, you got this stuff down pat. Questions? You want another quiz, Yuritsi? You want another quiz on Friday? That is a great idea.
No.
Let's do that.
Don't blame it on her.
You want a test on Friday instead?
Cynthia!
He's not going to give us a test.
I am going to give you a
He's
test.
asking when the test is.
The test will be the Friday before spring break.
Oh!
I won't
That's
be-
a
I
week
won't
from
be
this
here.
Friday.
I'm not going to be here.
Yeah.
And I guess you're going to have to come and figure it out afterwards. You'll do it the Monday after spring break.
Yeah, I won't be here.
Dude, no, that's not fair.
Why is that not fair?
Because half of us are
Half
going
of
to
your
be
class are not going
I-
to be here, Mr. Burnett.
The half that are, they get an advantage if they don't have to take it after spring break.
Okay, but that's not fair. Can we take it before?
You think you're going to be ready for it before?
Sophia's always
How
ready.
far before?
We're leaving on Thursday. Yeah.
So you're going to be here on Thursday?
No.
Oh, well, we're never going to be done with all this stuff by
Yeah,
then.
we're gonna be here on Thursday.
You want to come after school on Thursday and do it? We can do
We're
that.
leaving like Thursday afternoon. We're leaving
Like they're
Thursday
flying there. Yeah, we're
Leaving
Well,
at
then I
12.
guess we'll have to figure something out. But again, the Monday after spring break is not a big deal for me. I can put you in the room right next door.
I won't be here the Monday after spring break.
When are you coming back?
Wait.
Wait, are you after all of spring break?
No, we're coming back that Tuesday. We'll be here for that Monday after.
So it's a 4-day trip?
And you're paying that much money for a 4-day trip.
We're doing a whole bunch of
Um,
I mean, did you pay how
I'm
much
scared.
for it?
Don't be scared.
Yeah.
Hey, questions. This is that's not that hard. And guess what? No particles, no volumes,
No
simply
moles
masses,
and moles.
simply formula, mass, and moles.
But am I gonna be able to remember it all after 2 weeks?
It's not remembering it. Learn it. Learn how to do it. Don't remember it. Learn how to do it. What's your address? What's your phone number? What's your birthday? You memorize those
I
things.
actually don't.
You learned them. Goodbye, ladies and gentlemen. Go away. Have a good day. Adios. Arrivederci. See you later. Goodbye. Those are $1. That's $2.
Okay, Mr. Bear.
Oh, you got like $5 in your hand.
I know, I'm giving 6 for 2.
Go away. Go. There are people waiting for you. I don't know who, but there are. Go.
Also, I have a question. When are we gonna get our goggles? When are we gonna do something with it?
You're doing your lab, I think on Thursday.
This Thursday?
Why would I lie?
This Thursday? I don't know. Mr. Bear. Last 2, I swear. This is the last 2. Man, this is so stuffed today. Ever since I woke up, my nose has been stuffed. Even in my dream, it's been stuffed.
That's too bad. Now get out.
Okay.